Bismillahirrahmanirrahim. Exercise 3.4, question number 4, part 4. Integral square root of 3 minus 4x square into dx. The formula for integration by parts, integral of f of x gx dx equals to, considering f as first function and g as second function. First function constant, integral of second minus integral derivative of first function into the same integral, and then we close the bracket and then we have dx. Let's see what do we need for this integration. The results that we need for this integration are, we must know integral of 1 dx equals to integral of dx equals to x plus c. Derivative of square root of 3 minus 4x square equals to 1 by 2 times square root of 3 minus 4x square into d by dx of 3 minus 4x square, which is derivative of 3 is 0 and derivative of minus 4x square is minus 8x. Here, that is the application of chain rule. 1 by 2 times square root of 3 minus 4x square into d by dx of 3 minus 4x square. As a result, we get this 2 and minus 8 got cancelled, and finally, the derivative of this expression is minus 4x by square root of 3 minus 4x square. We will, when we will need this result in the solution, we are going to write this answer directly. And integral of 1 by square root of a square minus theta square into d theta equals to sine inverse theta by a plus c. The important point to be noted for the application of this result is that whatever we have here in place of theta, its differential must be here. Now let's see, let's go for the solution. And I have named the integral as I. Let I is equal to square root of 3 minus 4x square into dx. I'm going to introduce a 1 here. Integral I is equal to square root of 3 minus 4x square into 1 into dx. Introduce a 1 here. And now we are going to perform integration by parts, considering this expression as the first function and this one as the second function. Now perform integration by parts. Integrate by parts. So let's see what I will get. Integral I is equal to first function constant, integral of second minus integral bracket starts derivative of first function square root of 3 minus 4x square into the same integral bracket close and dx. So integral I becomes square root of 3 minus 4x square into x minus integral. This derivative is, write the result from here, minus 4x divided by square root of 3 minus 4x square into this result is x, and then I have this dx. Here it is. Now I'm just arrange the expressions a little bit. X into 3 minus 4x square minus 4x square divided by square root of 3 minus 4x square into dx. Remember that you must keep this negative sign inside, don't take it outside. Okay, now what is the next step? I am going to add and subtract a 3 in this numerator. As a result, I will get x into square root of 3 minus 4x square minus 3 minus 4x square minus 3 divided by square root of 3 minus 4x square into dx. Now we will split this fraction into two fractions and we will have x into square root of 3 minus 4x square minus integral, write a bracket here, 3 minus 4x square divided by square root of 3 minus 4x square minus 3 divided by square root of 3 minus 4x square, bracket close, and a dx. Now use a simple algebraic result here. X by square root of x is equal to square root of x. Apply this result here. As a result, you will get 3 minus 4x square divided by square root of 3 minus 4x square equals to square root of 3 minus 4x square. Just apply this result here. And you will get this I is equal to x into square root of 3 minus 4x square minus integral bracket starts square root of 3 minus 4x square minus 3 divided by square root of 3 minus 4x square bracket close, and I have a dx here. Now next I am going to write it like this. I am going to open up this integral. As a result, I am getting x into square root of 3 minus 4x square minus integral square root of 3 minus 4x square into dx, then minus and minus becomes plus integral 3 divided by square root of 3 minus 4x square and a dx. What next? Just have a look at this expression. Compare it with the original expression and you will see both are the same. So in place of this, I am going to write I. And I write the next step, xi is equal to x into square root of 3 minus 4x square minus I. Bring this 3 outside and you will get 1 by square root of 3. Just see what I'm going to do with this 3. I'm going to write it as square root of 3 square. What about this minus 4x square? I'm writing it as minus 2x whole square. Why I have written it? I will explain it just now. Just see, I'm going to perform integration with the help of this formula, and in this formula I need a square, not a. So I had 3 here, so I wrote it as square root of 3 whole square. As a result, I have the value of a now. The value of a here is square root of 3, and here I need theta square. I had minus 4, I had 4x square, so I wrote it as 2x whole square. So now I can see theta. The value of theta here is 2x. Now let's go for the next step. Bring this I over here. This will become I plus I x into square root of 3 minus 4x square plus 3 integral. I'm just writing the denominators right now. And I get it like this, square root of 3 square minus 2x square, and I have a dx here and I have a 1 here which I have not written. Why I have not written here? I am going for some rough work. You see, if I have theta here, then I need d theta here. Now in place of 2x, in place of theta I have 2x, so it means I need differential of 2x over here. What is differential of 2x? It is 2 dx, but I have only dx. What I am going to do now, I am going to divide and multiply by 2, so that I have 2 dx here. If you don't like to write 2 here, you may write it like this. Some students like to write 2 with dx, so just keep it here, one over there, and write a 2 here. Now you can see 1 by square root of, in place of a you have square root of 3, in place of theta you have 2x, in place of d theta you have d of 2x, which is 2 dx. Now this is ready for this integration, and you can write the result, this result, with theta equals to, what will be value of theta? 2x, and with a equals to square root of 3. So on this side I get 2i. On this side, I have x into square root of 3 minus 4x square plus 3 by 2. And I use a bracket here. And here I'm writing the answer of the integral, which is sine inverse bracket. In place of theta, I have 2x. In place of a, I have square root of 3. And I close the bracket and I write a C1 here. And now what? I like to use this bracket, a little fragile bracket here. Let me try this one. Here it is, 3 by 2 and bracket and all this. Okay, and now what? I is equal to x by 2 square root of 3 minus 4x square. When I divide both sides by 2, I get by 2 here, I get by 2 here. As a result, I will have 4 here, and inside the bracket, I have sine inverse, I have sine inverse 2x by square root of 3 plus c1, and now I will close this bracket. Okay, and now what? Just open up this bracket and you will have I is equal to x by 2 square root of 3 minus 4x square plus 3 by 4 sine inverse 2x by square root of 3 plus 3 by 4 c1. Now just put 3 by 4 c1 equals to c, and you will get your answer. I is equal to x by 2 into square root of 3 minus 4x square plus 3 by 4 sine inverse 2x by square root of 3 plus c, and that completes the solution. Now let's discuss that if a student does not use this bracket here and write it like this, I am just writing this expression. If a student writes it like this, 3 by 2 sine inverse 2x by square root of 3 plus c1, that is, the student does not write this 3 by 2 with this c1. Here you can see I have written c1 inside the bracket. As a result, when I will open, this 3 by 2 will be multiplied by this c1. But if a student does not do this and uses just a c1 here outside the bracket, then what will happen? Then its result will be 3 by 2 sine inverse 2x by square root of 3. And what is the next step? We have to divide both the sides by 2. So it will get 3 by 4, and here we will have c by 2. And then what he or she will do? Just put c1 by 2 equals to c. And you will see he or she will get the same answer. No difference in the answer. That is why I use these lighter brackets here, just to show you that this is the right way of doing it. But this is technically correct way. But as c1 is an unknown constant, so if a student uses it outside the bracket, it is okay. It won't make any difference in the answer. Okay, that's it.